Okay, so this one here, it's hard to tell what type of system this is because it has an xy in it. However, when we solve for systems, really we're looking for, we have two variables and I have two relationships, so technically I should be able to solve this. So the strategy I need to use here is, well, how do I get rid of an x here by subtract xy? I can't get rid of this x by itself without doing something to the y. So in this case here, it's probably easiest to isolate either the x or y and substitute it in. So in this case, I'm going to use the second equation here, and I'm going to solve for y. I'm going to isolate the y, and I'm going to use that as a substitution. So I'm going to use the substitution method here. So I end up with 2x minus 6 is my equation for y, and I'm going to use my like for like replacement. So that is equivalent to that, which is equivalent to that. So when I write out my new equation, it looks like this: 3x, I'm going to replace the y with 2x minus 6. Okay, so that's a like for like replacement there. Plus x minus 65 equals 0. Okay, so what is this going to, this generates then a quadratic equation. So then I have to solve this quadratic equation. So I have 6x squared minus 17x minus 65 equals 0. I can check to see if this is factorable, but I suspect it's probably not factorable. Well, we can see. So we can plug it in, 6x squared negative 65. Now, we're probably going to need a calculator to do this, but we're going to end up with 390. Okay, x squared. So we're looking for two numbers that multiply to 390 and have a difference of 17. Okay, well, 390, the factors of 390, we can guess and test this, but it looks like we're probably going to have some difficulty with this. So like we can do maybe 13 and 30. Okay, so if I do 13 times 30, if I have negative 30, positive 13. Now this isn't an easy one to guess, but this one does work. We end up having a difference of 17. So I end up with a common factor of x here, and it looks like I have a common factor of 5. Okay, negative 5. Along this axis here, I'm going to have a common factor of 13, and this is going to be 6x. Okay, so there's my factoring. So I'm going to end up with 6x plus 13 and x minus 5 equals 0. This one you may want to choose to use a quadratic formula just because it looks a little bit harder to factor here. Okay, but in the end we can factor it. So I get a solution x equals 5. Okay, when I plug x equals 5 into that equation, it looks like I have x equals 5, y equals 4. Okay, so my solution's there. And then I also, so that's one set. I also have x equals negative 13 over 6. And the y value when I plug negative 13 over 6. So that's going to be negative 26 over 6 minus 36 over 6. And so that works out to be negative 62 over 6, which simplifies to negative 31 over 3, or approximately 10 and 1/3 or something like that. Yeah, negative 10 and 1/3. Okay, so again, I just want to double check this work here. So 2 times negative 13 is negative 26 over 6, yeah. And 6 minus 6 is negative 36 over 6. That works out right. Okay, so this is my other solution. So I have two intersection points. Okay, x equals negative 13 over 6 and y equals negative 31 over 3. Now, since this is a new equation, so we can be fairly comfortable with knowing that this is a correct solution because algebraically we've been very consistent with it. However, since this is a new equation that we're really not familiar with, it's probably a good idea to just sketch a graph of this. So I go back to my graphing tool. Okay, so when I graph 3xy plus x minus 65, okay, I end up with a graph. Now it's a funny looking graph. It's a graph that's going to look like this. Okay, so it's actually a rational function. Okay, it's going to look like that. And when I plug in the other linear equation here, okay, we end up with 2x minus y minus 6 equals 0. Okay, so this is a straight line equation. Okay, so this one is my straight line equation, and I'm going to have something that looks like this. I have my intersection here. That's going to be at x equals 5, y equals 4. Okay, and then I have another intersection at this point, and Desmos has given me a decimal of negative 2.167 and negative 10.3 repeating. And again, that coincides with this coordinate here. Okay, so that's negative 2.167 or 16 repeating, and this is negative 10 and 1/3 or negative 10.3 repeating. Okay, so my graph, although this is new and strange, it is consistent with how we understand how we can solve systems of equations. We have two variables, two equations. We use substitution. But since this is a new format, the solutions actually, when we graph it, look like this. Okay, so this again is a new, something that's relatively new to us. But the idea is still the same, two variables, two equations.